Okay, so first thing we're going to do, where does the graph of tangent of 2x have its vertical asymptotes? Remember the tangent of 2x is always going to be the sine of 2x over the cosine of 2x. So whenever the inside of the cosine is 0, makes the cosine 0, that's when you're going to have division by 0 and asymptotes, right? So you got to figure out, if you look at the unit circle, the cosine is 0 at the 90s and negative 90s or 270s. So you got to figure out what makes the inside of cosine pi over 2. So in other words, when 2x is pi over 2, or 90 degrees, you're going to get 0. That's what we learned, right? So you can just set the 2x equal to pi over 2, and we'll do negative pi over 2. Negative pi over 2. So positive or negative pi over 2. So you're going to divide by 2 to solve for x. Same thing as multiplying by a half. So you're going to get x is equal to positive or negative pi over 4. So that's the answer there. X is equal to positive or negative pi over 4. That's where the asymptotes are. Okay? That's a separate question. You're not graphing that down here. See question number 1. Now question number 2 says, sketch 3 full cycles of y is 2 times the tangent of x. So 2 times the tangent of x. The inside first, so the first thing you're going to do is your asymptotes. So you're going to set x equal to positive or negative pi over 2. And there's nothing to solve. So that's where my asymptotes are, positive or negative pi over 2. Over here we had to divide by 2. Here we don't. We're just done. It's kind of nice and easier. So positive or negative pi over 2 will create our asymptotes. Now, the next thing you want to do is start graphing it. So you know the midpoint is the 0 on the tangent. Cool. And now we're just going to, so we did our midpoint, or our 0. 0 is your midpoint. And then the third thing we're going to do is, remember how we multiply positive and negative 1 by the amplitude? So the amplitude is 2. So to the right of our midpoint, we usually mark off a point 1. So it would be half the third quarter, or halfway in between the midpoint and the right asymptote would normally be 1, but we're multiplying that by 2. To the left of that midpoint would be negative 1, but we're doubling that to negative 2. And there it is right there. Now it wants 3 full cycles. So just give yourself another asymptote over here. And then you just duplicate the stuff. Everything's symmetrical. So there's 2 full cycles. And I'll go to the left. My midpoint to the right is 2, to the left is 2. How's that? 3 full cycles.
Can you go over the step 3 one again?
Well, remember to the right, the third quarter basically, when you're graphing the tangent. The third quarter, that's the second quarter is half and first quarter of it. The third quarter is usually 1.
Yeah.
But we're multiplying it by 2 in this case. So 2 times 1 is 2.
Okay, got it.
The first quarter is usually negative 1, but we're going to multiply that by 2, so negative 2.
Yeah.
So it just kind of, just like with amplitude stretches up, the sine and cosine does the same thing with the tangent, it stretches it. Okay?
Got it.
We're good?
Yeah, thank you.
Why? I'm going to leave the way on 3.
What's up? Oh, did I mess that one up? Yeah, that one should have gone through here and here. My bad. Good catch. Thanks, Jack. Okay, you guys cool with that? Now this is one. These grade easily. I mean, when myself or just about any math teacher in the world grades these, this is like a 5 point or a 10 point. And you got five important things here. You got the asymptotes, the midpoint, and the sides. So 1, 2, 3, 4, 5. You gotta have all 5 of those. Okay? And then you got the graph really. In the general shape, sometimes we'll put a point on. You know, if you make it like a zigzag, that's not what it looks like. So you gotta know it's a smooth curve. All right? You good? All right. So let's go to the next one. Okay, write the equations. Now, is it a sine? The first thing you want to do is sine or cosine. So is it a sine or a cosine? Cosine graph, because it doesn't start at 0. Okay, so we know it's y is equal to a times the cosine of something times x. Okay, so let's fill in our blanks now. Now, cosine usually starts at 1. This one starts at -2. So what's my a going to be? Catherine? -2. Awesomeness. Catherine's on fire. Okay, now we have to figure out how many full cycles in 2 pi length. That's called our period. Right? That's the length of a full cycle. I mean, that's called our frequency. That's how many cycles from here to here. How frequently cycles happen. Frequency. This looks like one full cycle, right?
Yeah.
So this is just 1x. So your answer should be y is equal to -2 times the cosine of x. Done.
Can you leave out the x in the parens?
That's fine.
Okay.
Now you can put that in your calculator, duplicate the window, and check it if you like. You can do that. Like, you know, I've got this thing. Let me see if it works. Do you guys want to see me look at it in my calculator?
Yeah.
Let's look at it in the calculator real quick, because I see a couple of people saying, "Yeah, let me show me your calculator." So let's see. It'll be quick here. So on your calculator, what you want to do is, I'm going to clear my y equals. Clear. Remember, I'm going to make sure my mode is in radians, because that's what this is in, 2 pi. I'm going to go to my window, and it looks like this one goes from looks like -pi/2 to 2 pi. So my x minimum is going to be negative second pi divided by 2. And my maximum looks like 2 pi, 2 second pi. And my x scale is looks like every pi/2. So let's do pi/2, second pi divided by 2. And then my y min looks like it goes from -2 to 2. So now when I plug in my graph, it's going to be -2 times the cosine of x. And when I hit graph, it should look something like this. Sure does, right? Looks like I nailed it, didn't I?
Yeah.
Okay? Because remember, this is pi/2, pi/2, pi, 3 pi/2, and 2 pi. So that's got it. Cool? Okay, now the bottom one, all these questions on this learning check are meant to be one's pretty straightforward one, and then one more challenging to get you thinking. So the same process is what we're going to go through here. We have to first decide whether it's a sine or a cosine graph. So what do you guys think?
Sine.
Yep. Y is equal to some number times the sine of some number times x. Okay? So let's get our amplitude first. It starts going up, so it's going to be a positive a, and it goes up to 2. So I know that this is going to be 2. Now the question is how many full cycles in 2 pi? Well, let's go to 2 pi. So basically you need to know how much of a cycle that is. You know that sine goes up and then down and finishes. So this is a half a cycle. This is a quarter of a cycle. Quarter of a cycle. So if a quarter of a cycle happens in 2 pi, the frequency is equal to a quarter. I'm sorry. Yeah. Quarter. The frequency is equal to a quarter. Quarter of a cycle in 2 pi. So this is going to be 1/4 x, or x/4. Okay? Does that make sense? Remember, this is the number that tells you how many full cycles into pi. How much of a cycle into pi. So we look at 2 pi, we draw a box around it. That's only a quarter of a cycle in there. It's a half of a hill. There's 2 hills. There's a hill and a valley in sine, right? So this is a half a hill. So a half of a half is a quarter. So our answer is going to be y is equal to 2 times the sine of x over 4 or 1/4 x. It doesn't matter. Now again, you can plug in your y equals screen 0 to 4 pi, and it should look just like that. What's up, Tor?
Oh, when you're done with thinking about looking like there's something on.
Sure, sure. Any questions on this one? We're good? Let's go on to the next one then. Okay, now, cotangent of x. Let me shrink this up a little bit. Actually, I'll put this down here for now. First, let's graph 2 times the secant. So for the secant, the first thing you want to do is recognize that that's 1 over the cosine. So let's graph 2 cosines of x, because that's the reciprocal of 2 secants of x. Okay? Now, the cosine normally starts at 1, but this one, it's got an amplitude of 2, so it's going to start here. It's going to finish at 2 pi. The middle is going to be a minimum, and the quarters are going to be zeros. So I'm just going to drop that down.
Wait, it says it.
What's up, kid?
It says sketch these 3 full cycles.
Yeah, 3 full cycles. I'm just going to do 1 for now.
Gotcha.
Yeah. Okay, so now there's my graph for cosine. Now I'm going to go ahead and, for the second step, I'm going to look at my asymptotes. So everywhere the cosine is 0, namely pi over 2 and 3 pi over 2, the secant is going to be 1 divided by 0. So everywhere you see a 0, you want to put an asymptote. So far, so good? Now, now we're ready to sketch the secant. It's going to match here and go down. Match there, go down, go up, go up. Now, the graph of secant is what you see in blue. The rest of the stuff is just a visual aid to help us graph. It asks for 3 full cycles. Looks like we're only going to fit 2. So let's just go ahead and duplicate it to the left. So again, 0, minimum, 0, maximum. A little vertical asymptote where you see the zeros. And we can just keep on filling in. We can finish this side now. You can finish that. And you can finish that. That's 2 full cycles. That's all there's room for. But that's fine. Okay? We cool with that? We good? Okay, now. This is graph the cotangent of x. So let's graph the tangent of x and do 1 over. So the tangent of x, you got a 0 here, asymptote there, 1, -1.
Is the asymptote's always going to be on pi over 2?
A negative for the plane tangent, yeah, this is the plane cotangent. So what I'm doing is I'm sketching y is equal to the tangent of x, and then I'm going to flip it. I'm going to do it that way through symmetry. Okay, so there's a graph of tangent. I'm going to do 1 more. Actually, 2 more. Let me do 1 over here. Midpoint, 1, -1. Okay, now. So at these asymptotes, tangent is 1 over 0. So the cotangent's got to be 0. So at the asymptotes, you can just plot zeros. Now, at the zeros, the cotangent is 1 over 0. So where there's zeros, I'm plotting asymptotes. So far, so good? Just think about it as 1 over, as the flip. Now, if this is 1, the cotangent is 1 over 1, so it's got the same points. So now I can go ahead and sketch this puppy. So now I can do another asymptote here, and then, so this is the graph of the cotangent. And that's it. That's a graph of cotangent for you. Just again, just graph the tangent, 1 divide all the critical points. Keep an eye on the asymptote. So that 1 over 0, so 0 divided by 1 is 0. Okay? And again, you can check that in your calculator. You know how to graph cotangent in your calculator? Yep, just 1 divided by the tangent. So if I want to look at this and make sure I did a good job, I can just get out my calculator, go to y equals. Now this looks like it's negative 2 pi to 2 pi. So let me go to my window. I'm going to go negative 2 pi to 2 pi. I already got that. My pi over 2 is cool. My y minimum looks like, what I got, 1, 2, 3, 4, 5. So y min is going to be negative 5. Y max is going to be 5. Y scale is that. I'm going to go to y equals, clear it, and just do 1 divided by the tangent of x. And now when I hit my graph, look like what I got in blue? Looks good, right? So you can check and make sure you did that right. Cool? Tori. Oh, in a second. Anybody else with this? Are we good? Cool with this question? All right. So,